all, again, basically, I have started my journey with Wipro R&D. So there, I have worked on a couple of R&D projects on deep learning sites. Basically, there was one domain called explainable AI where I have worked more. Then there, I have worked on a couple of more problems like security-wise and other things by using deep learning. Then I moved back to Sony. So there also I have worked as a senior data scientist. Basically, I was mostly involved with the object detection, post estimation, all that kind of problems. Then I was working on the product side for one company, basically where we were using recommendation engine and other things to which can basically make some kind of decision which will help the business. And right now, currently, I'm working on retail industry where we are using deep learning and other AI concepts, which basically allows us to give some kind of insights to the uh, seller, basically to increase his selling. Okay, that's a simple way I'm telling. So I have been mostly working as a data scientist for different organization where I put my skills on deep learning. It basically goes into the algorithms. We try to build new algorithms which basically can solve in business problems. Okay, that's all. So basically, we are taking one business problem and we are just doing some kind of research how we can solve that problem using AI or like deep learning. So that's our daily goal. Uh, for this role particularly, we deal with the data and we build complex algorithm and we just solve the problems. So this is from my introduction side. Uh, uh, so shall I start with the webinar?
Yes, you can carry on.
Okay, sure. Give me 1 minute. Okay, let me share my screen. I believe you all can see my screen having
Yes,
PPT,
sir,
right?
your screen is visible.
Yeah, sure. So basically, first thing is like why deep learning? Why all of you have come for deep learning, right? So how actually this deep learning journey started? So first, there is a concept called AI. So what is AI basically? AI is something just like intelligence plus machine. Okay. So when I put some kind of intelligence on machine, basically it will be AI. This is the simple fundamental for AI. If you see here, so I just want to build a machine having intelligence who can think on its own, and it just gives me the decision. I need not to put my brain there. Okay, so this is the whole fundamental of AI, and different use cases of AI you can see here like game playing, robotics, natural language processing. All of these are coming under AI. Okay? So AI is a broad domain basically. Inside AI there is a part called ML. So what we do in ML basically, right now whatever logics you are putting in any algorithm or anything you are writing, okay, so basically you are putting the logic, you are putting the if else condition everywhere. Okay, but in AI basically we are writing one program basically that does everything. We need not to do it further. Okay, so let's say I just want to do some kind of classification. So if I have built a classification for, let's say, this particular images, 10 images, if there is an image, 11th image is coming, so I don't want to write another logic for that. Okay, so it automatically detects that. So for that, basically, we are using our statistical approach and we just put it that into the code form, basically called as algorithms, and that we are calling it as ML, okay, machine learning. So earlier also the formulas, the algorithms were there. Let's say, for example, linear regression is an example of machine learning algorithm. So earlier also regression was there. That was statistically there, but now we just convert that into the code form and to implement it, and we are using that to get insights from the data. Okay, so that is what ML does. Now deep learning is a subset of ML. So how deep learning is different? So why deep learning? Basically ML was previously there. Now the deep learning came because of a couple of reasons. One is called feature extraction, which I'll tell you. Second thing is ML can't handle big volume of data. There are a lot of algorithms in ML, like regression, random forest, SVM. So many algorithms are there. But why deep learning came? First thing is there are every time you can't think that the data is linear. Basically, we are dealing with linear kind of data in ML. But when there are a huge number of non-linearity are present in my data, so basically I will go for deep learning. Okay, so it handles big amount of data, it handles non-linearity, and it handles the feature extraction problem. Okay, so first we'll see what is machine learning. It basically leverages my computer to automatically learn, which I tell you in AI, right? It automatically learns, and we need not to program it further. Okay, so how a ML process works, I'm telling you. So basically, this is my input. Let's say I have one data set. Let's say having some rows and some columns. Okay, let's say for example, let's take a simple data, which is basically an Excel file. So I have some rows and some columns. Okay, now I just want to make a prediction. I just want to make a classification model. Let's say I have the data of 100 customers, and I just need to make prediction that whether this customer is going to purchase tomorrow or not. Just simple. So what I'll do, I'll take the data from those 100 columns. Basically, I'll find out which columns are important for me, because there are columns having the similar kind of information. Let's say the temperature in Celsius is in one column and the temperature in Fahrenheit is in another column. So I can't take both the columns, right? Because the columns have the same kind of information. So from those data, first on that data, input data, I will do some kind of pre-processing, some kind of methods, okay, where I will be removing some rows, some columns by some methods. I will generate my training data on which I will build my model. So when I'm telling you a model, what's a model basically? Model is some kind of mathematical computation, okay? Like algorithm. ML model is I'm doing some kind of ML algorithm. So I will build on that training data, which will basically give me the prediction whether this customer is going to purchase or not. This is how ML cycle works, okay? Algorithm cycle. So you have the data, you have the algorithm, you will put your algorithm on the training data, and you will generate one output. Okay, in a simple way, I've told you. I'll focus more on the next slides. Okay, so why then deep learning? ML was there, and if you see, the process of deep learning is also, overall process is kind of same, only the algorithm parts are different. Okay, so why deep learning? First thing I told you, this is called feature extraction. So what is the feature extraction? Like, why this is an important thing for us? Okay, so okay, let's say I have 100 columns. As I told you, I need to figure out which columns are important for my model. Okay, in deep learning, that thing we need not to take care. You just put the data, it will automatically handles the feature extraction problem. But in ML, you need to do the feature extraction, where uh, if you have 100 columns, all the 100 columns should not be moving to your training, into your model, okay, as training data, because there will be there are columns which are duplicated, there are columns which doesn't add much value to my model. Okay, let's say the name of the customer doesn't add value to my model. Okay, because the name could be anything, but the geographical location may contribute something to my model. So we need to figure out those columns. Okay, so all these kinds, so all the columns are called as features. So we need to find out which features are important for me. That is the important thing, which we need to do in ML, but we need not to do in deep learning. Okay, so let's say what are the differences. Basically, first thing, when I tell you in ML we need to do feature extraction, so after doing all the feature extraction and everything, the data will be mostly structured data basically. But in deep learning, you can just give the data, you can push the data, it will basically give you the output. So similarly, in ML, we need to put, there is a need of human intervention. Like, we need to put so many things, we need to do so many things in ML. Okay, it's not just the code running, model building, or just putting the algorithm and getting the output. But in deep learning, uh, it's not that much work. Okay, while working on deep learning, it's just the algorithm and the code building side. Okay, but ML is simpler one. We can say we can compute it on CPU. We need not that much high computation like deep learning. Okay, and obviously it will take some lesser time to get run, but deep learning obviously takes time. And use cases wise also it's different. ML use cases we can do mostly for forecasting, prediction, or some kind of analytical interpretation, some kind. But deep learning basically solves complex problems, like basically, if you have seen the examples like robotics domain also, or just like self-driving cars and all other things like vision domain, natural language processing, all over, like in all the areas you can put deep learning. So mostly what is the aim of using this webinar is basically we just want to see the concept, algorithms, and the trends which follows deep learning basically, and how deep learning can be used in different industries. Basically, whatever algorithm or anything we are using, the end goal is to solve a business use case. Okay, it has to solve some problem. So we are just we are going to talk about how we can leverage our deep learning algorithms, which can basically solve complex problems in different industries like retail, healthcare, and all. Okay, so how we are going to move, basically we'll first understand what is deep learning, then what are the different categories, like examples of deep learning, like where we can apply our deep learning algorithms methods, then how it can what are the use cases of deep learning in different industries, how it can be leveraged more in the retail industry, what are the problems we can solve in retail industry, similarly for healthcare, and then we can see the challenges while solving deep learning. So first thing is like, what is deep learning basically? So in linear words, we can say it's a combination of different machine learnings. Okay, more machine learning with non-linearity, I can say. So in machine learning, basically, let's say some kind of regression problem or anything, we have just simpler. We are assuming that the data has to be linearly separable, and we are using some numbers of weights. Okay, just we are doing the repetitive modeling computation, and you are just finding the weights in normal ML. But in deep learning, it's a heavy number of neurons, heavy number of multiplication, and also the non-linearity. We are using different functions to impose the non-linearity. So basically in ML, we are assuming that the data is linearly separable. That's why we are putting, we can say, easier algorithms on the data. But in deep learning, we are assuming that the data is complex and the data is not linearly separable. It has a lot of non-linearity. And to handle all those non-linearity, basically we are using complex algorithm on top of that. Okay, so basically we are using neural network for deep learning. So basically, if you see in the diagram, everything is a layer. Okay, so let's say first layer, second layer, third layer. In every layer, there are much more neurons. Okay, and each each neuron in each layer is connected to the every other neuron in the other layers. So like that, the information passes. I will show you in the next slides. So first thing, what is deep learning? First thing. So deep learning is basically machine learning plus representation learning. So now you know machine learning, but what is deep representation learning? So I told you when I was talking about machine learning, we need to do the feature extraction. Basically, when we will provide a data, and we need to do the feature extraction, and at the end we are generating some features, okay, on which we are basically going to put our model. We are building model by putting our algorithms. But in deep learning, we are not doing that part. So that part is called representation learning, and how it is being done. Like, what is representation learning for me? So basically, if you see, representation learning is a set of methods that allows a machine to be fed with the raw data and to automatically discover the representation needed for detection and classification. So it's just for an example I'm telling you. Let's say you want to build a face detection method. So you just put the face for the as a data, okay, for the model. It will automatically generate the feature vector for me. So deep learning network automatically calculates the feature. You are not doing anything. You are just putting the data. It will compute on its own and it will generate the feature vector on top of which you can put any ML algorithm, or you can again put deep learning algorithm to get the classification. Okay. So this is how deep learning works. So we need not to bother about the feature extraction or like what are the features, broad, like high level features or low level features. We need not to bother about it. Automatically detects the feature. Okay. So just see like how it's different from ML. If you see, there is an input and there is a method called feature extraction which we need to perform. Then we'll put some kind of algorithm. Then we will uh, classify whether it's a male or female, let's say for an example. But in deep learning, you just put the input, it will tell you automatically whether it's a male or female. Okay. So that's the beauty of deep learning. That's why it has a wide use of like wide range of use. Okay. So how this deep learning, like what is the concept behind this deep learning approach? So if you see a neuron, you might have studied in class 9th or 10th, basically how our neuron is structured in our brain. Basically, if you see, these are the inputs for the, so from this channel, the information are going, then again, it is the one neuron is attached on the other, then like the similarly. So basically the information is passing from bottom to the top. Okay. If you see, there are like 9 to 10 channels of information, the way it comes, and there are 8 or 9 channels to leave. Okay. So the information passes. So just same similar concept we are using in deep learning. That's why the name itself is called neurons. Okay. So basically, if you see, this is my structure for deep learning. So if you see, these are my neurons. Each circle is called neurons for me. Okay. So just I'm taking one example. Here you can see transfer function. Okay. So basically, each neuron has some functions. Like if you see in neuron in our brain, basically each neuron, there are 8 ways of coming the information. Okay. So information are coming and leaving the neuron. So like that, here if you see in one neuron, the inputs are coming from all other neurons in the previous layer. Let's consider this layer. So basically, if you see for this particular node, the information are coming from this node, all the 4 nodes, okay, on the previous layer. So the information are coming from the 4 different nodes. And if you see, the information are again going to the next 5 nodes in the next layer. Okay. So this is the working process for neuron. Now, what do you mean by when I'm telling the information are coming and information are leaving? So basically, these are all weights value we are we have given here. So let's see, if you see for this particular neuron, let's say the input is x1 from xn. There are n inputs. So n inputs are coming into n neurons. Now, in every neuron, we have some weights. Okay. So this weights gets multiplied. Let's say, for example, W10. This is one weight. Okay. This is some number. When I'm talking about weight, this is basically a number of setup numbers. Okay. So basically, one weight is associated with one neuron. Now, this input is being multiplied with this particular number. So this x1 is getting multiplied with W1G. Now, this will give us some number. Like that, input 2 is getting multiplied with second, okay, second weights. Okay. So W2. So it will give us another number. Now, there is something called bias also we add, but we are not going to talk about that. So basically, all these things for all the n inputs, it gets multiplied, and we just take the summation of that, and we just passing it as the output from that neuron. Okay. Obviously, we'll add non-linearity and so many other things according to the neuron. So this is how a normal neurons working process. So just think, when we are talking about deep learning, it has so many number of neurons. Okay, just like 1,000 neurons or 2,000 neurons. So it's just like 1,000 inputs are coming, they are getting multiplied with 1,000 neurons. Then they are producing 1,000 outputs, and each output is going to the another 1,000 inputs in the next layer. Okay, just like that. So how complex is the multiplication and other things you can just think of. Okay. So you can just see a normal diagram for deep learning here. So all like the 4 are the input neurons. So 4 inputs are coming, then they are getting multiplied in this layer. Then each of the output is going to all the 4 neurons in the next layer. Then again, the same thing is happening in this layer. Then again, it is generating 4 different outputs. Then this 4 output is going to every other neuron in the next layer. Then similarly, it is coming to the end. So when it is coming to the end, then we are using some layer called softmax layer, which basically gives the output between 0 to 1. And we are predicting some like classes, we can say, like some kind of output we are predicting. Okay, some value. So now you are asking me, sir, how exactly these things are happening? Like, so this is all coming under the deep learning algorithm side. Okay, I'm going to talk about that. Okay, and this is the basic, like we can say, easier version to understand. So you can see, this is the input, all the input layer. Then these are called hidden layers. This is called output layer. Okay. So let's say you want to build a classification model having 2 classes. Let's say male or female. So basically, I will be assigning this node for male and this node for female. So how generally a deep learning process works? So let's say for we will take an example having male or female. So I'll be giving my input. Okay. Let's say I have an input of 100. So my n is 100, for example. So I'm taking an input of 100. Now this 100 is getting multiplied. So all these weights value, these numbers are randomly initiated initially. So our goal is basically we have assigned randomly numbers as weights. Now I will do training, model training. And after doing rigorous model training, when my training ends, basically I will get the new numbers. Basically, these numbers are getting updated in each iteration, okay, in model training. So at the end, I'll be getting the new numbers, which will be my weights for the model. So now how these numbers are getting updated, that is called as optimization process. So if you know ML process, basically in ML also, if you see some kind of regression model, basically we need to find those weights, actual weights. So for that, we are basically, we do the model training. So how we do the model training, we are using some kind of optimizer, let's say gradient descent. So how a normal ML process works, basically you have the input, you have assigned the weights, you have just initiated the weights, okay. Now you have a training, like in supervised algorithm, basically you have a training for, like you have a label file, so-called annotation. So for each input there is a corresponding output. So with those output, you will basically first declare a loss function which basically calculates the loss, okay. By using those loss function, we'll calculate the loss, and our main goal is to optimize that loss, minimize that loss. That is the normal ML process. The same process happens here in deep learning, okay. So we have the input. Now we have designed our weights, okay. This is the structure I'm going to use, and the randomly initiated numbers also first initially we need to give to the model. So after, so now how the training process works, basically the inputs getting multiplied with the random numbers and it will generate a random output, okay. Now I have got two outputs for two neurons. Now I have my label file having, for each image there is an associated tag, right, whether it's a male or female, that is called label. So I have my label file. Now I will use that label file with the input. I will first declare a loss function. Let's say I'm using some kind of log loss. So I'll be using my loss function and I will calculate the loss. So once I calculate the loss, I will update my weights according to the loss because I want to minimize that loss. Okay. So once I update my weights, again I will do the same process. Again I will find the loss. Again I will update the weights. This is how a training process works. Okay. So the same process we used to apply in regression also, we are using the same process in deep learning, but the challenges here are different, okay, because it's a deeper network. So sometimes there are multiple problems for deep learning. You can feel like there is something called vanishing gradient. What is called gradient? Basically, when we are updating weights, how we are updating weights basically. If we are using gradient descent or some kind of formula, basically there we are minimizing the gradient. We are using some term called gradient. You might have studied in mathematics. So we are finding the gradient with respect to each weights, and we are subtracting that. Okay. So sometimes what happens when you are using deeper layer, let's say 100 of layers, okay. If you see here, there are three hidden layers, right? This one, this one, this one. So when you use multiple hidden layers, so there is a time when you are coming back, you are updating weights, the gradients value will be much more lower and it becomes zero. So when you want to update the weights, it basically doesn't update the numbers because the gradients are just kind of zero, okay. So that problem is called vanishing gradient. So with the benefit, there are certain problems we get in deep learning which we need, which basically we solve while implementing deep learning. So there are multiple challenges in deep learning. So we have to impose our non-linearity. So we use generally the ReLU function or sigmoid function. Like that, at the end layer, I told you we use softmax function, okay, to get the value between 0 to 1. Like that, this is how a deep learning normal process works algorithmically. So now you will see the benefits of, or characteristics of deep learning. Basically, it does the automatic feature extraction, which I already told you, and it handles high dimensional data. Let's say when you want to do a face detection, your image has to be the size of around 300 cross 300. So that thing, like 300 cross 300, it means 90,000 inputs for one particular image. So it's basically one particular data point has a 90,000 inputs, which we can't directly use, okay, for ML modeling. So this kind of high volume of data it handles. Then the beauty in deep learning, which I love most, basically it automatically detects the high level feature and low level feature, okay. which we are going to see on the next slides in CNN. Basically, there is one network called convolutional neural network. Then it's already has representation learning, which I told you, which basically detects the features and all. And it also solves the unconstrained problems like in different domains such NLP, vision, and other domains. It basically solves the problems which we can't solve using our normal logic or anything. Okay. So there are these are the normal softwares which we use for deep learning. Nowadays, so many algorithms and so many use cases are already implemented in this library, like in TensorFlow, in PyTorch, and all those things. Like you can directly use the object detection API and you just build the object detection model in TensorFlow and like that. Okay. So now you'll see what is the beauty of deep learning, which I told you. If you there are uh, you might have known this thing, okay, supervised and unsupervised learning. So I am just going to tell you this thing. So basically, in supervised learning, we have the training data. Like for the training X data, we have the training Y data. Means we have the label, which I told you. Basically, we have the input and the corresponding output for the training data, by which we are basically finding the loss and we are building the model. This is called supervised way of learning. But there is one algorithm called unsupervised. So where we don't have the label data. Okay. So basically we have only the input for training data. We don't have output. So in those algorithms, basically we are doing some kind of computation on the input itself to gain some kind of insights or to gain some kind of information. Okay. So let's say, for example, it's called clustering. So I have one, let's say I have 1,000 points, but I don't have corresponding label. So in clustering, what we do basically, we basically categorize my data into different clusters. So for which I don't need a label file. Okay. So this is one kind of algorithm. So we will see supervised. Okay. So where we are using CNN, convolutional neural network. Okay. How this can be used. So first we will see what's a CNN. So CNN is a network. Okay. In deep learning, like basically there is an operation called convolution operation. So what we do in convolution, let's say I have an image. Let's say for 100 cross 100, I have an image. In convolution method, basically, we have certain kernels. Okay, kernels means filters. Let's say I have 10 filters, and each filter has size 5 cross 5. Okay, this is my convolutional layer. So I have 10 filters having 5 cross 5 size, and what these filters basically do for me, it basically detects features in the image. Okay, that is the beauty of convolution. It does the convolution operation, which basically does the dot product and take the sum. Okay, and they generate some kind of what I can say, they generates the features. Okay, let's take, I have 100 cross 100 image, I have 5 cross 5 my kernel. So what it does basically as a convolution operation, first we will put on the top position in the image. Okay, from 0 to 5th cell on the width side and on the height side. Okay, so basically I'll put that I will do the convolution operation. Let's say 0 to 0 1, I'll do the multiplication. Okay, so I'll have right now 25 numbers. Okay, for 5 cross 5, I'll take the sum and I'll generate one number. So basically this one number in my output represents those 5 cross 5 cells, those 25 numbers in the input. So like that, I will shift my kernel. Okay. Earlier I used to do for 0 to 5. Now I'll go for 1 to 6. Then I'll go for 2 to 7. Then I'll go for 3 to 8. Like that, I'll move till 100. This is on the width side. I will do the same thing for the height side. Okay. Again, I'll come back to 1 to, on the height side, 1 to 6. Then on 1 to 6, I'll again move from 0 to 5, 1 to 6, like that in the width side. So it's just kind of rolling. Okay. It's just like, let's say this is my image. I'll just first put on this position, the kernel. Okay. Then I'll go like this from here to here, left to right. Then I'll come back on this position. Then I'll go from here to here like that. Then I'll go like this. Okay. So basically I'll generate one output. So for an input of 100 cross 100, I'll basically get an output of 96 cross 96. Now the beauty is this 96 cross 96 basically represents my 100 cross 100, which has the, basically this 96 cross 96 has all the information which I want to build the model and which basically represents those 100 cross 100. Now, what are the different methods we use here, okay, while building model using CNN? So basically, first is the convolutional layer. You can see. So basically, I'll have different kernels. Let's say 10 kernels means I'll get 10 different outputs, okay, for 10 different kernels. Now, what I'll do, I'll use some kind of pooling layer. So what's a pooling layer? Basically, in pooling layer, uh, let's say my pooling size is 2 cross 2. So from that four numbers, I will pick one number directly by picking one number or doing some kind of computation over here. But that one number basically represents those four numbers, okay? It's just like taking the number having highest value, or just like kind of taking the feature, okay, top feature, and leaving the rest, okay? So again, it will in pool, basically, if you have 96 cross 96 output, basically after doing pooling, it will become half, okay, 48 cross 48, because I will take 2 cross 2 and I'll put one value for that. So 0 to 2, I'll put one value. Now 2 to 4, I'll put another value, like that. So now this 48 cross 48 basically represents my image 100 cross 100, okay? Then I will put some kind of non-linearity, let's say some kind of ReLU method or sigmoid. Then I will use again convolution, okay? So now this 48 cross 48 again become 44 cross 44. So now that 44 cross 44 represents my 100 cross 100, okay, image. Now that 44, I will make this as by using pooling, I will make that as like 22 cross 22, okay? Like that, I'm just reducing my dimension by keeping maximum features, okay? I can't guarantee you the 100% features, but maximum features. So just think in that way. So like that, I'll be using 5 or 6 set of convolutional pooling layer, okay? So at the end, I will get a feature vector of, let's say, call size 10 or 12, anything I want, okay? So if you see here, basically he'll using convolution, then pooling, then convolution using, and generate one feature vector, okay? Then we are using, let's say, one or two fully connected layer or required number of fully connected layer, and we are basically predicting our output. So how we are doing that? Just think. All this convolution and pooling are generating one feature vector, let's say size of 10. Now this 10, on top of this 10, I'm using two neural network, okay, having size 50, 40, or anything. And I'm just generating my output. So those neural networks are called modeling. But this generating this feature vector, here we are generating the features, right? So basically, I'm generating a vector of size 10, which basically represents my image of size 100 cross 100. This is the beauty of CNN. And those 10 values are basically important for um, important for me to build a model, okay? The image is not important right now. That 10 information, that 10 feature size, the which feature vector of size 10, having almost all the information for that image. When we are using machine learning, that's our work to find that feature vector, okay? But in deep learning, it automatically gets found, okay? So that is the beauty of deep learning. Now we will see how actually it finds the features. So just think, let's say I have a face having size 100 cross 100. So if I'm putting a kernel of 5 cross 5, basically how much place it captures on my image? It will capture hardly an edge of nose, or like curvature of my eye, or something like that, na small portion. So that is called high level feature, okay? So you can see on the first image here. So basically there are diagrams. So basically it just finds the curvature or something like that, because 5 cross 5, how much pixels it can capture, right? So because of that. But when you're going to the next layer, let's see, from 100 cross 100, you have made it into 96 cross 96. So one pixel in 96 cross 96 basically represents 5 cross 5 pixels, 25 pixels in my original image. Now those 5 cross 5 in 96 cross 96 getting converted to 48 cross 48. Now that 48 cross 48 again gets converted to 44 cross 44. Now that one pixel in 44 cross 44 represents more than 25 pixel in my image. So it will, let's say for example, it is representing 60 or 70 pixels. So now it will come here where it will capture half of my eye or half of my nose, okay? Now just go to one more layer deeper. Now your output size is 11 cross 11. Okay, just think. So now that one particular output basically covers entire your face. Okay. So this is how we are like the convolution is providing output. So that particular one number in that feature vector represents my entire eye, okay, or entire nose. So if that particular one value is low, then it will not basically think that the face as a nose or something like that. On top of that numbers, basically, it is building the prediction. So if you go into much deeper and see the numbers and analyze those numbers, you can also directly tell by seeing the feature vector. Okay, if it's a small size feature vector, generally we generate the feature vector of size like 512, 1024. So we can't directly tell in our naked eye. That's why we are using some kind of ANN to build the model on top of feature vector. But if it's a feature vector of size 5 or 6, you can directly tell by seeing the numbers. Okay, whether it's a yes or no, some kind of prediction. Okay, so this is how CNN works, and it's the beauty of deep learning. It uses in basically it is being used in so many places. Okay, like self-driving car, where anywhere, any place where we are using vision. Okay, computer vision, image detection. Basically, we are using this particular thing. Now there is one another network called recurrent neural network. Okay, so how it is different? If you see in normal neural network here, input from one particular layer is going to all the neurons in the next layer, but not in the same layer. Okay, but in recurrent neural network, we are putting the information on the same node. If you see here, the information from input 1 is going to h1, is going to all the other node, but it is not going inside again in the input on the same node. Okay, but in recurrent neural network, we are putting the information on the same node, output on the same node. Why there is a need? Because we are dealing with sequence inputs. Okay, in CNN we are not dealing with sequence inputs, but in recurrent neural network we have designed this neural network basically to handle the sequential input. Let's say I just want to build a sentiment analysis model, which basically finds the sentiments of the sentence. So now I let's say my sentence is I am very much happy today. So all the inputs, all the sequences, if you see, that are correlated. Okay, so M is dependent on I. I am happy. Happy is dependent on M. So it has to come after M. Okay. So these are all sequences. So first I will push I on my node. So if you see in this image, okay, so this all these are called nodes. Okay. So just see the inputs are coming, X0 is coming, then it is generating an output of O0. Now O0 is coming and the input X1 is also coming. So basically O0, this output is coming. So out again, the same output is going on the same input. Okay. So this is all the same node. Okay. This func, these are all the same node. So when I'm putting one input, the output again itself is going on the same input, so that the information of I will be fed with the M. So this is how the sequential input is getting used in the neural network. Okay. So this is one what I can say network we are basically using. So there are higher versions of this network also right now, LSTM, KM, and so many other things. But now you'll ask me, sir, what is the use of, what are the users of this network? There are a lot of use cases. So entire NLP, I think most of the NLP algorithms, we are dealing with the sequential inputs. Okay. So whatever the text pre-process, like text processing, whatever the text related use cases we are doing, where we are dealing with the text, okay, writings, anything. Let's say machine translation, where basically we are translating the language, basically sentence from one language to another. We are dealing with sequences. So I just told you one example. So like this, there are a lot of examples where we are using this kind of recurrent neural network. Okay. So now we'll see the applications of deep learning. Okay. So what are the different applications of deep learning? So as you can see the example, this is a normal like face detection. So what's a detection? Basically, we'll plot the portion. Okay. So in the image, so you can see I have just identified the face. Okay. So basically different. So this is one set of use case of like deep learning. Now you will see other. Now this is, if you see Google Lens, basically I'll take the image and it will tell me what the image is. So this is also one kind of captioning problem. Okay, well, I'll take the image and I'll just generate some kind of captions for that image. I will tell you what that image is. So this is also a deep learning image. Okay, so how we were tackling this kind of problem? Basically, we are from the image we are generating the feature vector. Now I'm classifying that feature vector or that image into some classes. Okay, let's say I have 10,000 number of classes and I'm just classifying it. Okay, so let's say I have taken one image of a flower. Basically, it will put that into the flower class, and it will show in the output that's a flower. Okay, now visual translation, you can see basically in the other language, if it will, you will take a snapshot and it will just get you through the original information. Okay, you can convert it into anything. Okay, this is how a visual translation works. Now self-driving cars, I think most of the people love that. In self-driving cars, basically there is no drivers, and it just the cameras are there. It will take the snapshot of the road and it will automatically gives you the direction, okay, in which direction the car has to go, and just like that. So here also we are using deep learning, okay, because from the camera we are getting the output, and those images we need to do the image analytics on those images, okay, by doing deep learning and all. So we need to find out what those images are giving us, okay, from that road. Let's say if in the image, let's say there is one more vehicle in front of my vehicle. So basically it will show in the image that there is one vehicle at this much distance. So you just need to take left or right accordingly. So it will take the decision. Now, if you see automatic machine translation, so you just give the sentence in one language, it will give you the sentence in another language. So here we are using RNN mostly. Basically, it will take the sequential input, because the sequences in, let's say, for example, I'm translating from Hindi to English. So the sequence in Hindi is not similar to the sequence in English. Okay. So for that, we need to take care of those sequences. Okay. Now we will see how deep learning can be used in different industries. So at the end of the day, whatever algorithm we are building or whatever the code or anything we are doing, okay, but it has to have some kind of use cases. It should solve some problem. So today we are going to focus on how we can leverage our deep learning knowledge. Okay, we'll see how we can use this deep learning in the different industry. Okay, where it has to solve some kind of business problem. So first thing is the retail industry. So retail industry is basically whatever the retail purchasing you are doing, clothes and other grocery and everything. These are all retail industry. So how we can use deep learning approach in the retail industry? Basically, you can use some kind of recommendation engine which gives you the recommendation according to your way of purchasing. Okay, that's the beauty, like that's the best thing. Okay, so you just need not to put efforts to find something. Like in YouTube, if you are watching one video, it will automatically give you some recommendation in YouTube which generally you like. So basically 95% you will like, chances are there that you will like the video. Okay, so you will see that. So that's the power of recommendation. Okay, so just think how, if we use those kind of recommendation thing in retail, like that, nowadays you are purchasing in Mintra. So if you seeing some product on the below, if you go and see, there are caption called like view similar product, and you can see the similar products there. Okay, so that is the beauty of recommendation engine. And chatbots are there where which basically help you like what you are doing and other things, like what you want to see. Let's say when you are going to a store, basically you are asking them, okay, like I just want this kind of cloth having this color and this size and all. So basically the chatbot will ask you and you will just give your input. It will show you dozens of products and all, okay, which you are going to like. So this is one application. Then industry called healthcare. Basically in healthcare, there are a lot wide range of applications. Just see like disease prediction. Let's say you are going to the doctor and just you are going to check, like the doctor is taking your reports and telling that you have a fracture or you have a pneumonia. Okay. So just think if you build a model which can automatically takes the X-ray data and the pneumonia, this kind of images, X-ray images, and tell you that yeah, you have the pneumonia or you have the bone, and it will identify, like we do in object detection, right? It will identify that yeah, here you have the bone and what kind of you have the fracture and what kind of fracture you have. Just think, you can just put your X-ray reports on mobile and you just get the images where like portion where you have the fracture and what kind of fracture you have, and it will give you the automatic suggestion like what you need to do. So how much, like, it just reduce the 80-90% of the work of the doctor, right? So that is one use case where we can put deep learning approach, sometimes called like virtual nursing, because nowadays in corona, like, a lot of nuisance created, right? Nurses were not there, doctors were sorted. So in that case, you can use an AI built nurses, okay, virtual nurses, which can ask you different help, or like which can ask you different problems, where whom you can tell your problems and get your, just clear all your problems like that, okay. So that is the beauty of deep learning. You can build a virtual nursing, okay, where you can get all your answers, okay, which we generally ask to some compounder or like some doctors. Now, third thing is like manufacturing industry. So basically, when we are generating, like, doing some kind of manufacturing, there are products which gets damaged, right? Basically, when I'm building, some percentage of products are there which are damaged in the industry itself. So we can build some kind of models which automatically figure out the damage or something like that, which basically helps us reducing my main power, okay. So basically, let's say for example, I'm creating pipes. So while creating pipes, some are like, machines, like, let's say some pipes are not good, or like the dimensions are little different or something like that, which we can automatically, which can be automatically detected by AI, just think, and we can just put that into our garage, for, which we are not going to sell basically. So just like that kind of problem, if AI can solve, just think in that way. Then another industry called aerospace and defense. Basically, we have satellite images. So now just, if we can use some kind of deep learning algorithms, or leverage our knowledge from the deep learning, and you can find out which are the safe zone where our troops can go and just put their tent and all those kind of things, okay. So that it will be beneficial for our defense or like aerospace problem, like industry. uh, Another one is called like automobile industry, where basically, self-driving cars and automatically damage it. Let's say if there is an accident, so manually one person has to go and see the damage and all. Just think, less, we have one machine and which can automatically checks the damages and all. So that will be beneficial for us, right? So these kind of problems use cases are there where we can put our AI engine, deep learning engine, which basically solve those complex problems. Even it's not 100%, at least it solves majorly, let's say 96, 98% of accuracy. So we can just use that, okay, as a broader approach. So let's say, in medical domain, even if your model is like 99% accurate, you can't, the doctor directly can't use that, right? So you need to set a threshold, right? So let's say, when we are generating some kind of prediction model, it basically gives us some prediction scores. So from, let's say, 0 to 1, if it is giving me 1, then I can think, oh yeah, it's negative, okay. Or if it's giving me 0, then I can think it's a positive. But if it's giving me 0.5, what I can do, what decision can I make? We can't make any decision, right? So we can't use that output for the medical thing, because in medical, if you are giving 100%, like 100% correct result, it's fine. But if you are giving wrong result, like negative to positive or positive to negative to 1%, then it will be a nuisance for them, right? So for that, basically, we can use the deep learning approach, we can use the AI product, but up to some extent. But in other industry like retail, let's say if you are seeing the images, okay, so recommendation, let's say you are searching a shirt, how can we think, look, how can we build some kind of prediction that send this kind of campaigns to this set of customer, okay. Just normal, think a problem like that. So basically, all the customers are not same. Let's say we have billions of customers for one company, but how can I categorize my different customer for different marketing campaigns? This is one set of thought I can make, okay. Some customers are there who are basically discount prone customers. Basically, whenever they get a discount, they'll purchase. People are there who generally purchase during sale, Christmas sale or any sale, okay. People are there who generally purchase during off time. People are there who purchase like winter clothes before winter season. So all the categories are there, right? So how in retail industry you use deep learning? So we need to find out the relevant matrices. We need to find out the patterns. It might be in the what you can say spending patterns for the customer or from the company side, or it's the geographical location that matters. All these things we need to find out the anomalies. Okay, we need to find out the customer who are basically not contributing to my company. Okay, let's say if I am the owner of the company, I'll basically find out the customer who are basically are not purchasing anymore, so I need to leave them out of my database or something like that. Okay, so all those things are basically problems in like retail domain. So we will see what are the problems we can solve. So first set of problems we can solve is like basic one, recommendation engine. So whenever you are coming to my website, let's say I am clothing brand, you are coming to my website, you are searching for some clothes. So it's my decision to give you enough number of items that you have to purchase. Okay. So just like you are going to a shop, that guy, the salesman or whatever the person is showing you a lot of items, whatever you are telling, before you can think of, they are coming with the items. Okay. So that is the beauty of selling. So I just want similar things in on my I want to build similar kind of things. Okay, so I just want to build a recommendation engine which basically gives you 100% accurate things, okay, which you want. So that is one recommendation engine. This is one problem where we can leverage our deep learning algorithm to find the exact similar item. Okay, second thing is like all kind of advertisement, whatever the promotion I told you, the campaigns. For that we can use our deep learning. Okay, now one thing is called contextual shopping. So let's say you are visiting some kind of social media, so social networking site you are going through, and you just see some celebrity wears a particular cloth, okay, and you like that, you want something similar to that. So there are online tools where you can basically put that link of the story or whatever the video, and the tool itself takes the image and finds the similar item and it will present you. Okay, so there we can use our deep learning, which basically gives you what you want. Okay, you need not to do anything. Okay, third thing is basically on the security side, we can do some kind of video surveillance. Let's say you have a store, in the retail store people are going and purchasing. So now every time I can't uh, kind of like have view on every people. Okay, so I can build some kind of video surveillance system using AI, where I can detect the fraud or some kind of theft, like that kind of work. Okay, so that is, these are the areas where we can use deep learning in retail. We will see one by one. Okay, first, recommendation engine. So this is something like I love the most. Okay, because in your whatever you are using website or anywhere, you are using this recommendation engine. Okay, so everywhere, if you see YouTube, Netflix, anywhere, whatever you are watching, they use they will give you the same thing. You are using Mintra, you are using some kind of Flipkart, grocery, anything. So recommendation engine nowadays it's being used everywhere. So why like to build a recommendation engine? Okay, and how can I build that one? So there are a lot of data, and why can't we build this recommendation engine with ML? So first thing, there are a lot of data in retail. Okay, basically it will have every clicks. So let's say whenever you are going to purchase jeans, for example, so basically before purchasing, I think every people, they must have gone through a lot of like items and all those things, right? So all those data will be there. Even you are purchasing one time, but your visit in the website basically called traffics. Okay, so the traffic count will be too much. Okay, and your it took basically you are going, you are adding into your cart like 3 to 4 items, but you are purchasing one item. Okay, so the add to cart rate is also greater than your purchase rate. Okay, so there's a huge number of data, and we can't solve it with ML. Okay, normal. So we are using deep learning. So now, how can we build a recommendation engine? If you ask me, so I'm just giving a simple example. Let's say you have one image. Let's say image of a jeans. So now I can find the similar item from my database, but there are certain constraints because there are a lot of items in my database. Okay, but as there are certain constraint I can put before finding the recommendation. Okay, I can put the color or something like that. There are categories in the jeans. Okay, let's say jeans, there are subcategories, 10 subcategories. So whatever the cloth I'm finding itself has one subcategory. So it can restrict its search around that subcategory. Okay. So this kind of conditions we can put, it depends on the business use case and the company and everything. Okay. So basically, what we do in a recommendation, you can see segmenting users according to their personal data, including behavioral patterns and previous purchases. So this is one thing. Okay. So whenever you are finding a jeans, basically it will show you jeans, but it should also the company wants to sell something more to you also. Na? You are going to purchase a jeans, but if I'm the owner of the company, it's my responsibility to sell you also the shirt with the jeans. So how can I push the shirt to you? Because I don't know what kind of shirts you like, but it's my work to find out the most probable shirts which you like. Okay. So that kind of information from where we can get? I can get the same kind of information from your past behavior. Okay. You might not have purchased shirt from the company, but you might have purchased something else from where I can build some thoughts that this kind of shirts you may like. So this is also called coming under the recommendation problem. Okay. So this kind of problems we need to solve. Like right now in I was working for a clothing brand, so we used to solve this kind of problems. Okay. Now, if you see, like, I'll show you how recommendation works. Okay. So there is something called external data. So external data means the company data. Okay. So generally people comes to that company and what people loves most about that company. So let's say if let's say for Mintra, there is one brand called Roadster. So people are coming and purchasing t-shirts in the Roadster. So even if you are purchasing a jeans, but it's my duty as Mintra to show you the Roadster t-shirt because 99% people love Roadster t-shirt and the purchase rate is 70% from those 90% customers. So basically it's probability, the probability is more that you also may purchase the t-shirt. So that is external data. Then your internal customer data. Okay, basically what is the thing you want to search. Okay, and your past behavior inside. So that data I will what I can say and sums up both the data. Then I will use the geolocation data also because geographical location does matter during the purchase. Okay, so I will combine all three data and I will find the recommendation. So it's kind of heavy complex problem. Then I will give you some kind of suggestion. Okay, then you will see the items and you may like, then accordingly whatever we have shown you, if you are purchasing from that or you are not purchasing from that, we will evaluate a matrix from there to whatever the recommendation I are showing you, how you are reacting on those recommendations. So this is an evaluation matrix we will build and accordingly we will change our recommendation engine. Okay, so this kind of self learning process we will go through. So this is one example where we can put our deep learning. Now how we can put deep learning? Basically we can take the image, we can use CNN and all those things to generate feature vector. Now I will do some kind of similarity mapping on the feature vector. Okay, so generally simple example recommendation, a basic simple recommendation is basically you have the image of genes. I have, let's say, 10 genes and I want to find out the similar genes for this particular genes. Then I will generate the feature vector of all these 10 genes and this particular genes, and I will do the similarity mapping from all the genes. Okay, so from these 10 genes who have whichever genes has the higher similarity mapping, basically I will give you that. This is the simple problem I told you, but the recommendation which are being used in the Mintra and other, they are more complex. Okay, so now uh, certain things are there, like there is something called collaborative filtering, which are having basically the merchandise data and recommendation. Basically normal one is the personal data which I told you. Then there is a system called hybrid system which basically cover includes all the kind of data. So basically nowadays people use hybrid things because they want to do the cross sell upsell. Basically if you are purchasing item A, I want you to purchase item B, so that is called cross sell. I want you to do that. So that kind of benefits want companies want, so they are going for a hybrid approach. Okay, I told you the second thing is called contextual shopping, where basically there is a tool which does everything for you. Okay, it will find, it will take the cloth and it will find the similar clothes from the website and it will show you. So it just basically someone is doing it for you. Okay, so this is an application in retail which basically helps the customer. Third one is like chatbots and virtual shopping assistants. So basically if you are going to a shop, the salesperson is asking like what you want, sir. Then he will go, he will come back with 10 different products. He will show you like that. The chatbot, you can just interact with chatbots and it will send you, it will show you the different clothes, just like a virtual person is doing it for you. Okay, so that thing we can build. So chatbots basically we can build through NLP, because it will take the text from you and it will return the text to you. So it's kind of basically application of chatbots. Okay, then one thing is called delivery optimization. So one thing we can this thing we can use in our uh, retail industry, like how can we optimize the delivery point. Okay, so let's say whenever you are ordering something, so till you are getting the product in your home, it's the job of the company, okay, to deliver the product. Now while delivering, there is a delay due to weather or some kind of other problems like transportation problem and everything. So we can have a track of all these things, okay, by using AI. Like we can have camera and we can see what are the weathers. We can predict that the delivery is not possible for particularly these 3 days. There are heavy rain in that side. So all these things we can maintain using deep learning, okay. And while delivering, we can have the track, okay, and we can see which route is optimized, which route is not optimized. All these problems can be solved using AI, okay. So, and this thing, the Amazon has like implemented that thing, like they are basically, they have warehouse, okay, you are purchasing one product, so it's basically it's in the nearer warehouse you have. So whenever you're ordering, even if it is showing from like the product is showing from Calcutta, it is coming from the nearest warehouse. So is there any option like, I know that you are going to hit this, like you are going to purchase this item, okay, let's say if I'm taking one example, Christmas is coming, and I don't know what you are going to purchase, but can I know from your past behavior that what are the set of items which you are going to purchase on Christmas, before 5 days or 10 days of Christmas? If I can predict that, then probably I can send all the items to the store, so that there won't be uh, basically you can get the product, okay. So sometimes it's showing us now the order like items are not there, because those items are not placed in those warehouses. So that problem won't occur, right? Because if I know before that you are going to purchase this item, I will just send that items to the nearest like warehouse, and probably you can order that on the Christmas and it will be delivered to you easily, okay. So this is also something we can get from the AI or like using deep learning, okay. Now self-driving vehicles, as you know, just like using robots and other thing, so that you can just use basically using deep learning, using camera and all, and you can just the automatical automatically the basically you can just reach from point A to point B, okay. It's just like you need not a driver, but basically these kind of things are not 100% possible in Indian roads, but probably in foreign these kind of things are possible, okay, where the, because it needs a lot of things, okay, the roads dimension and cleanery, and because in Indians there are what you say holes and everything, so many things are there, traffic lights and, but these things are possible, okay, with the correct what I can say assumptions and inputs, okay. Video surveillance is comes under the security, which I told you. Basically, if I'm having a store, I can put cameras and I can just build an AI model which basically catches the thieves. Okay, whenever someone is doing something, what I can say bad, basically you can just it will automatically make some sounds or generates puts the alarm so that you can just go and pick the thing. Okay, you need not to sit in front of the camera for a longer time. It just automatically you can build a model and it detects the thief or something like that, okay. Now how we can use this deep learning approach in healthcare? Basically healthcare is a bigger industry nowadays, okay, so we need to use AI so that we can reduce some kind of bigger problems in healthcare. So basically in healthcare we have large medical data sets, okay, and how we can give back to healthcare by using AI? Basically we can take some kind of healthcare decisions by AI. So if we are providing that kind of insights, then that will be helpful to healthcare. Okay. So we will see couple of like examples where we can put our knowledge. Like one thing is called virtual nursing, which what I told you basically. Uh, there will be an app basically where you will ask the question and they will give you the feedback, or if you give the like upload the reports, it will give you back your like information about your reports, and it basically it will help you. as a normal nurse, okay, just kind of virtual nurse, okay. So I think some company has implemented like Molly, basically where you put your question and they will tell you what to do, what not to do, like a doctor tells you in person, okay. So that kind of help we can get. Then second thing is called high risk patients, okay. So uh, we can basically every time if you have problem, you are going to a doctor, they are seeing your reports and telling you have this disease and all. But let's say if there any intermediate model, okay, where you put your reports and if you are like we can say in a very bad position, okay, for that disease, basically it will directly tell you, no, 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 you are in very bad position and all those things. So just like finding the high risk patients, okay. So similar to these kind of things are being implemented by UiPath and other like robotics process automation companies, where basically it takes your data and gives you the feedback on medical. Basically, I have also done something on the pneumonia like side when I was in Wipro. So basically, we are building some kind of a pneumonia classifier. So we were telling them, okay, this is the region where the problem is happening, and you have the disease and like that, okay. So next thing is called roboted assisted surgery. Basically, you can use robots to do the surgery, and also this is a like very big thing, which are basically doing robots the surgery and all. It's a big thing for us, but it's just like you can train the robots by using AI and all, because it will involve a lot of cameras and lot of like robotics process. And for that you can see this kind of examples, okay, where basically robots will come and do the surgery like we do with our hands and all. Yeah, this is a new thing. It's interesting nowadays. Actually, it's being implemented, which basically hospital management optimization. So, basically, a lot of doctors are there and a lot of patients are there. So there are applications, okay, where basically if you show them your reports, previous reports or problems, basically they will suggest you the doctors or hospitals. Or basically, it manages the doctors to the patient's ecosystem. Okay, so that's the beauty that also we can do with deep learning, okay, because the data is huge, your reports are huge, and they will basically suggest you whoever is like the hospitals are vacant and like where you can easily get the treatment and like that, okay. This kind of ecosystem like a platform where we can do, just think like an Uber, okay. It basically searches you and give you the perfect ride, okay. Like that, just think hospital management optimization. So basically it will helps you to search the best hospital, and inside the hospital there are staffs, there are managements, right. A lot of patients are coming, a lot of doctors are there, so they have to distribute each of the people, right. All these managements if you can do through one software, okay. So there is one company, Globus.ai. Basically, he does the same kind of thing, which basically uses natural language processing, okay, to process your text data reports and all, and it will give you basically suggest to the perfect places to go for. Okay, then this is disease outbreak prediction. Okay, so sometimes in different geolocations, different different possibilities are there. Okay, for the diseases. So just think if I have all the data, okay, weather data and every other data where I can use like satellite data are there. I can use those and predicts previously. Yeah, this kind of diseases are like are about to come. Okay, like Corona came, right? So if someone would have predicted, okay, after 6 months, this or like after 1 month or 15 days, this kind of problems can come to this particular geolocation, then people will be prepared, right? Now because you basically gets alarm from the uh, what is government about the forecast and all, right? Whenever there is a possibility of tsunami or anything like rise in the water in the ocean, basically you get some kind of alarm, right? So just think about the diseases, okay. If some problems is coming and if you're getting that kind of alarm, okay, there is a possibility like 90% possibility that this kind of disease can come, so that you can just be prepared, or some kind of preparation you can take, right? You will get some time. So this kind of models also we can build from deep learning, okay. But there are a lot of analysis and lot of data will be involved. So and medical diagnostic, as I told you, like we can build some kind of classifier model which can basically does which can simplifies the job of the doctor, okay, which basically does 50% of 60% of the job of a doctor also. That is also fine for us, right? Because nowadays, let's say if you are going to any hospital, basically for one doctor there are like 100 patients. So just think all the 100 patients are not like that severe, right? 20% patients are only severe, 80% can easily be treated, right? So just think if we built an AI model which can treat at least 50-60% of the patients, then the traffic will be lesser for the doctor, right? So, and now the best part is like, what are the challenges in healthcare? So basically, in retail, challenges are there, but there are developments in the retail sides. Okay, but you will see here what are the challenges in healthcare. Basically, first challenge is the lack of data. Okay, because whenever you are going to build some kind of intuition model or some kind of patterns from the data, basically data has to be structured. Okay, not entirely structured, but the data has to have some meaning, right? So that we can infer some meaning, right? If the data is completely skewed, it doesn't have any meaning. How can I generate some kind of meaning from the data? So in medical domain, the data is very like lesser, we can say. In retail, there are a lot of data, but in healthcare, the data volume is very less. Second thing is bias. This is the interesting concept. Listen, whenever you are going to build a model, basically, let's say you are building a model having two classes, A and B. So you will basically for you will basically have the data in 50-50 order, right? So half data, something like that, like similar amount of data in both the classes. Or if it's not similar also, it's kind of little different, like 19-20 kind of thing. But in medical case, just think, if you have 100 people, then there will possibility that only 5% people have diseases. Okay, so your data will be 95-5. Okay, it's kind of imbalance. So due to that, you will get bias in your data. Okay, so this is a bigger problem in medical domain. So whenever you are solving a problem in medical domain also, like building some kind of model also, this is the problem we face in our day-to-day life. Okay, third thing is like lack of strategy. Basically right now healthcare is evolving, so we don't have proper strategy to build a model or solve the complex problem which will basically affect my retail, like healthcare industry. So this is something we need to like do research, or like we have to come up with some new ideas. Okay, and fourth one is like lack of in-house expertise, because whenever you are building a model, so basically we are collaborating with the business person, right? So when I'm doing a retail, so I have to have knowledge about the retail. Okay, it's not sufficient that I have only knowledge about software and code and AI. Okay, I have to have the knowledge of the domain so that I can mix the both and create a solution. So in retail, basically people have knowledges, but in healthcare, it's a complete different domain, right? So it's a doctor and they are completely different people. And AI is completely like mathematics, and it's just like engineering side. So combining both the things is very difficult and build a solution. Okay, so it's very difficult to build a solution for that. But people are nowadays working on that, working on the domain knowledge and trying to mix both the things to build a proper solution.